Hello friends, welcome to my channel. Today I'll be giving a short introduction going over the scope and the goals of this video series. So the goal is to provide a comprehensive motor control design guide. Everything from hardware design and simulation to software development. Through my design process, I found that there was a bunch of amazing resources out there. But I didn't find a single source that kind of covered everything I wanted to know. Furthermore, some of these resources were a little too technical and they were kind of overwhelming when I just got started. So I wanted to put together a series that covered the basics of motor control design and provided some links to resources if you want to learn more. So as I mentioned before, the intention of this video series is to cover the basics of three-phase motor control, specifically battery-powered designs, the kind that we find in electric vehicles and RC drones. I'd like to keep these videos relatively non-technical. I will be using some math along the way, but nothing that doesn't help convey the underlying concepts. I'll be assuming no prior electronics knowledge, so anyone is welcome to listen. That being said, motor control can be kind of overwhelming, so I'd recommend getting some basic electronics or embedded skills under your belt first. As a brief safety warning, please be careful while designing power electronics. The underlying concepts here can be used, in theory at least, to design super high powerful, high voltage and current motor controllers, like the kinds that are found in Tesla cars. Be very careful if you are working on anything high voltage. Use the proper PPE and don't work alone. Even if you're designing something low power, for example for an RC drone, lithium-ion batteries can still be very dangerous if abused. Don't take shortcuts and make sure you trust your designs. In general, I'd like to put out a video once every week or two, likely on Sundays, in order to be able to produce the highest quality content while still being relatively consistent. I want to make sure I don't bite off more than I can chew. So at least to start, I'm going to be doing the first few videos in this series as PowerPoint or a screen capture format, where I go over some basic theory and go over data sheets and that kind of thing. I'm aiming for about 3 to 10 minute long videos with a total of about 20 to 25 videos. From there I'll be making a bunch of complementary videos where I demo some PCBs and show some real life measurements. After that I'll be working through some actual design examples. So I'll set up a scope for a project and proceed to go through my typical design flow. Everything from sourcing parts to documentation to CAD, which I'll be using Altium for, simulations, which I'll be doing in LT-Spice, PCB fabrication, which I'll be using JLC PCB for, and then finally the whole testing and debugging and writing code. I'll be doing software development STM-Cube IDE. To conclude this video, I'd like to go over a rough outline of the PowerPoint videos I'll be creating. This isn't exactly set in stone yet since I haven't written the scripts for those videos, but hopefully it'll look something roughly like this. We'll start off with a high-level introduction. This will start off going over the basic AC motors and why we need a controller in the first place. From there, we're going to talk about the basic topology that we're going to follow, as well as go over the three-phase inverter. From there, we'll move into control, so we'll talk about some different commutation methods. This is how we generate the signals that control the inverter. We'll talk about six-step commutation, sinusoidal PWM, and space vector PWM. Then we'll go over different control methods. This is how we adjust our commutation to achieve the desired speed or torque. Specifically, we'll go over trapezoidal control, V over F control, and finally field-oriented control. Then we'll go over power electronics. This is probably going to be the hardest part of the design. It gets more and more complicated as we increase the power that we want to deliver to the motor. We'll start off talking about the different kinds of switches that we can use in this application, namely IGBTs and MOSFETs. Then we'll go over gate drivers. This is the intermediary between the microcontroller and the switches. Finally, we'll go over the DC link capacitor, which can kind of be thought of as a mini power source closer to the inverter than the battery pack. After that, we'll go over embedded design. This is all the low voltage electronics that we need to generate the correct control signals. So we'll talk a little bit about microcontrollers and some basic signal processing, and then from there we'll talk about all the different sensors we may or may not need. This will include current sensors, voltage, temperature, speed, position, and temperature sensing. Finally, we'll talk about voltage regulation. This is what we do to generate the power rails we need to power all the different systems. And finally, we'll be going over some examples. I'll be talking about the Texas Instrument Evaluation modules, the VESE, Axiom, as well as the ODrive. That's about it for today. I look forward to seeing you guys at the first video next week.